Hello everyone. Today we are going to talk about the research we did on analytical approach for inventory stratification and optimization under the guidance of Professor Wang. In this paper, we are mainly focused on building analytical models which helps the business reduce cost and increase the profits. Inventory classification is one of the pressing issues faced by the people in supply chain industry. Many researchers have been going on for many years to solve this issue. Most of the businesses still use traditional demand model for inventory management, which is where the inventory is classified based on the predicted demand and facing many problems. Some of the major concerns regarding the inventory management is higher buyout costs. Majority of the items have less demand or no demand, not able to decide whether profit should be given higher priority or the demand, high inventory holding cost, and poor space management. So in this paper, we are going to talk about different analytical models which helps us resolve this issue and allow the business obtain more profits.
This slide speaks about the approach which we adapted to solve this business problem. To begin with, we collected the relevant data from different sources and merged into one consolidated master file. Then we follow the conventional data pre-processing steps. For those variables which are needed for analysis but not being captured in existing process, we use calculated variables as proxies. For instance, we used 1 minute service level as stockout probability. Then, in terms of modeling, we compare 3 basic models and 4 advanced models. First, we enhance the existing demand model by segregating those SKUs with almost zero demand in a year. Second, in profit model, we prioritize to stock the profitable SKUs with consideration of demand. Cost criterion model is based on the existing literature, which considers factors like holding cost, buyout cost, and few more. In terms of advanced models, clustering techniques were followed. First, k-means clustering was adapted by providing equal weightage to different factors. Then, weightage based on business inputs were incorporated using analytical hierarchy processing. Since k-means clustering has a drawback of fixing the number of SKUs in a given cluster, fuzzy clustering was adapted to cater the potential capacity constraints. This slide gives a snap of the different formulas which we use while modeling. As you can see over here, almost 80% of the weightage was given to demand and profit, and the remaining was given to lead time and buyout cost.
After evaluating the models with the weighted fuzzy clustering performs the best, it is also a more flexible and advanced clustering method that the business could adjust the inventory and class size by the limitation of their inventory capacity and manipulate the importance of the factor that they value more. In the graph, we could see that the proposed model not only could classify less SKU in Class A, but also be able to capture high demand and high profit, which is better than the existing model. In both results in the product types, we could see that by only focusing on less than 10% of products, we could control almost 60% of demand, profit, and buyout cost.
Thank you, Jason. Once we had our statistical results, we worked with our business partner to get the expected business results if the changes were implemented. Based on an analysis, we could see that with fuzzy clustering, we will be able to increase the profits by 27%, reduce the buyout cost by 12%, and the inventory holding cost by 2%. Apart from that, instead of having just 3 classes, we can increase the number of classes so that the slow move and non-move inventory can be managed separately. Right inventory management can ensure that business can reduce the unnecessary overhead cost while improving the service levels for the end customer. With weighted fuzzy clustering model, we can not only ensure to get the optimized SKU stratification method, but it also gives us the probability of SKUs falling in different clusters, which in turn can help business better manage the space constraint if there are any. For our analysis, we worked with limited parameters due to the data unavailability. But in future, the method can be further improved if better data can be collected against the inventory. With this, we close our presentation and would like to thank our business partner, Professor Wang and Professor Lanham, for their continued support and guidance. Thank you for listening to us.